Welcome to another coding tutorial, and in today's video I'm going to show you how to create this interactive dandelion sketch using the faceMesh model from the ml5 library. Alright, before we get into the ml5 part, we're going to start by creating the dandelion first. So we're going to start by first just declaring a variable called letter. And then letter is actually going to be a string, a type string, and it is going to be writing the letter P for my name Pat. Alright, and then in draw, I'm going to use the built-in function called text to draw out the letter P. And all you need to do is to provide 3 arguments. The first one is the text that you want to write, which is letter. And then the second and third arguments are going to be the bottom left corner of where the bounding box of the text is going to be. So I'm going to actually put it in the middle of the canvas at width divided by 2 and height divided by 2. Alright, let's just click run. Next, we can use another built-in function called text size. And then we can change the size. How about 50? Alright, now the letter P is much bigger. And if I were to draw an ellipse at the exact location, width divided by 2 and height divided by 2, let's do a size of 10. You can see that it is at the bottom left corner. That's the anchor point at the moment. But we can change that anchor point, and I want to change it to be in the middle of this bounding box. So I can use another function called text align. And then if I put just one argument, center, you can see that it's centered around the x-axis, right? But if you provide the second argument, then now it is also centered around the y-axis. So that's what I want. Now I can delete this ellipse. All right, so now I want to actually rotate this letter, and I can do that using the rotate function. And we're gonna rotate it around a certain angle, right? How about I declare angle starting at 0, but then I'm going to actually map this angle to the mouse X location between 0 and width, and then how about we map it between the angle 0 and 2 pi radians, which is just 1 revolution. And if I click run, and then what do you notice here? It is actually rotating around the origin point, but now the origin point is at the top left corner of the canvas. So the rotate function rotates around the origin point. And if I want it to rotate around the letter itself, I need to translate the origin point to the center of the letter P and then rotate. All I need to do is put the translate function before rotate, and I want it to translate the origin point to this point, to the middle of the canvas, right? And then I can rotate this, and then now the text will be drawn at the new origin point. So 0, 0. And ta-da! Alright, so now it's rotated around the origin. If you have seen many of my videos, you would know that if we were to create a bunch of these letters, we also need to make sure that we put 2 functions, push and pop, before and after all of these transformation functions, so that when we start to create another letter, for example, the translation and the rotate functions will start from the default setting, which is where the origin is right here, and where the rotation angle is, which is whatever angle that you set at 0 for this case. Alright, so now what I want to do is that I want to create a class called letter. So I need to just click create file here, and then I'm going to name it letter.js. And then before we start writing a class, let's go to index.html and then copy this line of code and make sure that you reference the file. In my case, the name is letter.js, and now it is referenced. So now we're ready to write the class. Let's call it letter. All right, so inside the constructor function, first I want to give a position of where the letter is going to be, and I'm going to actually store this position in a vector, and a vector is an object that can hold 2 to 3 values, and I'm going to use it to hold 2 values, the x and y coordinates of where the letter is going to be. And I can use the method called create vector to create a vector this.position. So it's going to be at x and y location, and x and y are going to be the parameters for the constructor function. All right, so if I go back to sketch.js, I also want these two, letter and angle. And this letter will be P for now. And then this dot angle, let's start it at 0. Actually, I'm going to put it here. And then I'm going to write two methods. The first one is update. This is where we're going to be update the position and also the angle, the rotation of the letter. And then display is where we're going to display the text. And we're going to copy all of this. All right, let's put it in display for now. For angle, actually, instead of having it mapped to the mouse here, how about we just do this dot angle plus equals to this dot angle v, which is angle velocity, and we're going to set it at, how about 0.1. So basically I'm just setting the angle to rotate at a constant increment at 0.1. And then we need to make sure that this translate, instead of translating all the letters to the middle of the canvas, it is going to be at this dot position dot x, this dot position dot y. This has to be this dot angle. And then how about the size? Let's do this dot font size. Let's give it a parameter here, font size. This dot font size to be equals to font size. And actually, instead of the letter P here, I'm actually going to pick a random value from an alphabets array, which I am about to declare here. Ta-da! Okay. All right. How about we, and then this has to be this dot letter. How about we create just one letter? So let's go back to Sketch, and I'm going to set letter to be a new letter object at width divided by 2 and height divided by 2, and then we're going to give it a size of 50. And then inside draw, we're going to first update, which right now is basically just rotating the angle, and then we're going to display it. Save. All right, now we have a random letter that is rotating in the middle of the canvas. Perfect. So now let's create a number of letters that is actually positioned around a ring of circle at a specific radius. So what I want to do is that I want to first, actually, we're going to write a for loop that goes from I equals to 0 to I less than num, I plus plus. But what is going to be the num, the number of letters inside the circumference? And I want it to be depend on the size of the circumference. So what I'm gonna do is that first I'm going to declare r, let's do it at 100, and then circumference, the equation is 2 pi r, right? So 2 times pi times r. And then now that we have the size of the circumference, what we need is we need to calculate num. And it is going to be based on the size of the circumference divided by the font size, which we also need to declare. So let's declare it as 20. And this could be, and probably will be, a decimal point, right? But for num here, we need an integer. So I'm going to also use the function called floor, which basically round the number down to the closest integer. And then basically what we need is that, how about we set this as an array letters? So letters will be, so we can use the method called push to push a new object inside this array. So it's going to be a new letter, and the location will be x and y, which we're about to declare, and then size will be font size. So what will be the x and y coordinate? Because I want it to be along the circumference, right? So I want them to actually be evenly spaced out. So first I need to know the angle that will give that equal angle, right? So I'm going to declare it as 180 degrees. And then I'm going to declare it as 180 degrees. And then how about we set this as an array letters? So letters will be, so we can use the method called push to push a new object inside this array. So it's going to be a new letter, and the location will be x and y, which we're about to declare, and then size will be font size. So what will be the x and y coordinate? Because I want it to be along the circumference, right? So I want them to actually be evenly spaced out. So first I need to know the angle, that will give that equal angle, right? So I'm going to declare it as 180 degrees. And then how about we set this as an array letters? So letters will be, so we can use the method called push to push a new object inside this array. So it's going to be a new letter, and the location will be x and y, which we're about to declare, and then size will be font size. So what will be the x and y coordinate? Because I want it to be along the circumference, right? So I want them to actually be evenly spaced out. So first I need to know the angle spacing. So what we're going to do is we're going to calculate angle. And basically it is going to be 2 pi, which is 1 revolution of a circle, right? Divided by the number of the circle. And then that gives us the even angle between each of the letters. And then we just want to multiply it by I to know the exact position of each one. And then we're going to use trigonometry to figure out the x and y position by basically converting from polar coordinates to Cartesian coordinates. And the equations are x equals to r times cosine of angle, and then y equals to r times sine of angle. All right, so now that we have this, inside here, basically we just need to write the for loop, right? And instead of using num, I'm going to do letters.length. It should be the same, right? And then we're going to call update and display here. All right, okay, and now everything is based on the origin point here, which is at the top left corner. So we need to make sure that we move it to the middle. So let's do width divided by 2 plus here, and then height divided by 2 plus. Yay! Okay, so what I want to do next is that I want to create a bunch of rings. So let's start by first, do we want to keep the name letters? Actually, let's just do rings. And then let's create another variable called num ring. So a number of rings. Let's set it to 3. And what we're going to do is that rings is basically going to be a 2D array. So it's going to store all of these letters in the inner array, and then the number of rings is basically the outer array will be the number of rings. What we need is that we need the outer loop. So let I equals to 0, I less than num ring, I plus plus, and then all of this will actually have to go inside here. So first, inside this outer ring, we need to call, so I'm actually going to delete letters for now. So rings of I will be an empty array. And then we have all of this information, right? And then all of these I would need to be J, 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 and then J. And then instead of letters here, it will be rings of I and J, right? I think so. All right, and then this will also have to be a 2D array. So actually, before I write this, actually let's just write it out. So rings of I dot length, no, J plus plus, yeah. Okay, so let me explain what we're doing right now. So in the outer one, it has to be from I equals to 0 to I less than rings dot length. This is the number of arrays, the outer arrays, right? So rings dot length, which is going to be the number of ring here, which is 3, I plus plus, but then in the inner loop, it goes from J equals to 0 to J less than rings of I. So this is going to be the number of objects inside the inner rings. So rings of I dot length, and then J plus plus. And then here it will have to be rings of I and J dot update, and same thing for display. Let's see. Push. So to use push, basically we push it inside the outer array. So if I were to do rings of I and J, I basically just need to set it equals to this new letter. So this should work. But if I want to use the method push, then I just do rings of I push dot push, and it should work as well. All right, so you can choose the way that you want to do it. But as you can see, all of the letters are in the same position, right? And that is because the circumference, no, the radius is all the same. So how about we change that as well as the font size based on which ring it's in. So I actually also want to, let's set the velocity, angle velocity to 0 for now so it doesn't move. And then let's start the radius at 30 plus I times 15. How about that? Okay. And then let's do the font size from 10 plus I times 3. And I also actually want to set it to 5 rings. All right, that looks pretty good. So the next thing before we start moving the letters here, I want to also upload new fonts so that it looks a little bit better. So all we need to do is first we need to upload the font. So you come to this arrow here, click the plus sign, and how about we create a folder so that we can organize all the fonts. So let's call it fonts. And then to upload all of this, just come to font here, click this arrow, and then click upload file. And then you basically just need to drag and drop your font files in there. So I uploaded a total of 3 fonts. So p5.js-regular, Canit-black, and Roboto-regular. So what we want to do next is that we want to preload all these fonts into the sketch. And we can do that by first, we want to declare. So usually if you only upload one font, you can just declare a variable font. But I actually have 3 fonts. So I'm going to create an array called fonts. And then I'm going to write a function called preload. And how we preload the fonts is that we basically, so now I want to populate this array. So the first position, font of 0, will be equals to another function called load font. And then inside here, we need to tell it where it is. So in my case, it's in the folder fonts, and then it is the name of these files, right? So inside the quotation mark, you just put in fonts. You put in the directory of where your fonts are at. So fonts \, and then I'm basically going to write out all of these names. So p5.js-regular.ttf. All right, and I need to do 2 more times. So 1, 2. Change this to 1 and 2, and then the second one is going to be Canit black, and then the third one is Roboto. Okay, let's just click run to make sure that it's okay. Okay, it's fine for now. All right, so what we're going to do next is actually here. How about we just do let font equals to fonts of I. But because we have a total of 5 rings, but we only have 3 fonts, we need to make sure that when I equals to 3, right, it goes back to 0. And we can do that using a modulo expression, which is an expression that returns the remainder between the division of 2 numbers. So if I were to do I mod, which is this percentage sign, and then fonts.length. Fonts.length right now is 3, right? So when I is 3 divided by 3, it gives you a remainder of 0. And so that's why when I equals to 3, it goes back to the index of 0. So it basically just loops through your array without giving you an error. But now it's going to give us an error if we don't also actually put in font here. I mean, it wouldn't give us an error because we actually have not updated the class. But what we want to do is that we want to give the object letter another argument, which is font. So let's go back to letter.js here, put in font, and then this .font will be equals to font. And we can change the font by basically just use the built-in function text font, and then this .font. I think that's just it. Let's try it. Nice. As you can see here, right now what I'm using is basically just random letters, but what if you do it as like a poem, a sentence, whatever you want to do. Okay, so now how about we move these letters around? So what I'm going to do is I'm going to create two more vectors. The first one is velocity, which I'm going to set at, how about 0 for now. And then the second one is acceleration. And to update the position, basically we can update the velocity, which is the change in position, or we can update the acceleration, which is a change in velocity, which in turn would update the position. But to do that, we need to also update these vectors, right? And so since acceleration is the change in velocity, so basically what we need to do is that we can add two vectors together. So this dot velocity dot add this dot acceleration. So by doing this, we're updating the velocity vector with the values from the acceleration vector. Then after that, we want to update the position with this new updated velocity. So this dot velocity. Okay, and so let's say that right now we give 1 to the x component of the velocity vector. And so our letter is basically just moving 1 pixel at a time, right? But if instead of changing the velocity here, I change the acceleration. As you can see, the velocity is updated because the acceleration is updated, and it looks like, which it is, speeding up to the right. So that's what we want to do. But instead of giving it a constant acceleration here, what we're going to do is that we're going to write a function called apply force. And basically we're going to give a force, and this is going to be a force of when we blow the dandelion, right? The dandelion, yeah. And we're going to basically update the acceleration vector with this vector, which is the force. But if we were to do this, we also need to make sure that, because before the acceleration here is constant at 0.1, right? And so it's not changing at all. But by doing this, we're basically adding this force vector to acceleration, and it's going to be adding over and over again each draw loop, right? So what we also want to do is that we want to reset the magnitude of this acceleration to 0, such that it's not accumulating and it's just going to be super fast. So what we want to do is we want to just put in this dot acceleration dot melt. So basically we multiply it by a factor of 0. So we clear the values. And so now what we need to do is that we basically need to create this particular force so that we can make it looks like the dandelion is being blown away. All right, so let's go back to Sketch. So inside draw here, what I'm going to do is that I'm going to say that if mouse is pressed, so this is a Boolean variable that returns true when the mouse is pressed and returns false when the mouse is not. So if the mouse is pressed, I wanted to call a function called trigger, which we're about to write. So let's actually just write it now. So function trigger, basically going to take in the letter, right? So what we want to do is that we want to create a new force vector, right, that we will be adding to the acceleration of that particular letter. And this force vector is going to be based on where the mouse is and also where the letter is. So we can use a function called p5.vector.sub. So basically we're subtracting two vectors, and by doing that we can find a new vector that points from one vector to another. And we want to point from where the mouse is or where we're going to be blowing, right? So right now it's the mouse, and we want to have it point from the mouse to the letter. So the position really matters. So the first one, you need to put in where you want to point to. So letter.position. And then the second one is the mouse. So actually I'm going to put in mouth here. And right now the mouth here will be the mouse, actual mouse, right? Once we have this mouth vector, we know how far it is based on the magnitude of this vector, right? So we also want to set a variable called distance to be based on force.magnitude. And we can just do force.mag. And then I want to actually normalize this force vector. So normalize basically just keep the direction, but make the magnitude to be equals to 1. Then after that, what I want to do is that I want to map this distance that is between, how about we map distance? No. We're going to actually create a new variable. Let's call it magnitude to be equals to, we're going to map this distance here between, how about 0 and width. And then we're going to map it to 0.1 and 1. And then we're going to multiply this force by this magnitude. And then after that, once we have the force, then we want to apply the force, right? By what? By this force, the new force vector here. Okay, I think this is it. And then mouth here will be, when mouth is pressed, then this will be ring. So the letter is rings of I and J, right? And then mouth is basically a new vector at mouse X and mouse Y location. Okay, let's try this. If I'm in the middle here, looks nice. Okay, if I'm in this bottom left corner, okay. So everything is quite even right now because it's just based on the distance, which makes sense. But how about we make it a little bit more random? So instead of just mapping it like this, we then multiply it to a random value between, how about 0.1 and 1 as well. All right. Okay. And then we also want to change the angle velocity based on this distance here. So we're going to do letter dot angle v to be equals to map distance also between 0 and width, and then we want this to be smaller though. And let's randomize it by, how about 0.5 and 2. You can play around with these values. And all right. So now we have the floating dandelion. So now how about we integrate the faceMesh model from the ml5 library. So what we want to do is we want to go to the ml5 website, and then how about get started. And we're going to be using the faceMesh model. So basically we want the lip location, but I'm going to actually start with their examples. So they have 3 examples here. There's faceMesh key points. So let's start with that one. So it's super easy. From the website, as you can see, I can click the P5 sketch, and then we have this example. And look at that. It's kind of creepy, to be honest, but I'm loving it. So many key points. So what I want to do first is, how about I just print out this. All right, so actually let me first walk through the example for you very quickly. So let's look at the key components here. So we have a few variables declared here: faceMesh, video, faces, and options. So faceMesh basically is a variable that we use to preload the faceMesh model. So as you can see here, they're using the preload function as well to load the faceMesh model from this library ml5. And within the faceMesh model, they put in an argument of options. And options, as you can see here, there's what? Max faces, 1, refine landmarks, false, and flip horizontal, false. So max faces is the number of faces that you want to have tracked. Refine landmarks is set to false, but I believe this is where you can actually get even more number of points on your face. And then flip horizontal is basically flipping the model, and I'll show you how this works. And then there is video, and then there is the faces array, which basically keep tracks of the points. So inside setup, first you create the webcam video and then hide it. So basically the webcam tracks the face, right? But then they hide it because inside draw, we're basically using the image function to draw the video on top of the canvas. The video here is actually being drawn at the bottom of the canvas. And then inside setup here, there's another function called facemesh.detectStart with 2 arguments, video and got faces. It starts detecting faces from the webcam video. And then at the bottom here, we have that function got faces, which you pass in as an argument here, that basically returns the results of the location of the points on the face inside this faces array, which we declare up top here. Okay, so once we have this, then inside draw, we basically just draw out the video as you can see previously, right? And then here we have a loop, a nested loop. The first one goes through the faces array, right? So basically it asks, okay, if the face is tracked, then let's set face to be equals to faces, which I have printed out. So you can see here that it is a bunch of, it's a 2D array. So the outer array are the key points, which has a total of 468 points, which are the points that you saw on the face previously. And inside here, it gives you basically the X and Y coordinates and the name. And Z also. I'm not sure what the Z means here. And then the name of the location. So of which part of the body of the face it is. So this is lips. Then we have, this is still lips. This is still lips. Then there are other parts of the face as well. But what we actually want to use is actually these other parts of the face that comes in its own thing. We have box, we have lips, left eyebrow, right eyebrow, face oval. What we want to use is actually the lips object, and we want to use the X and Y coordinate and the width and the height. Oh, and it has center X and center Y as well. So this is what we're going to be using. Okay, all right. And yeah, so this is the first example. So I'm gonna close this. But the one that I actually want to use is actually the faceMesh parts. And let's see what it does. So basically, as you can see here, it only tracks the lips, right? So it tracks the lips. So if it's being tracked, that means the faces.length is greater than 0. And then faces of 0.lips, then we get the information, right? So the information that this is displaying right now are lips.x, lips.y, lips.width, and lips.height. And then we draw the rectangle around it, and then at the bottom here, we draw all of the key points on the lips. I'm going to be copying and pasting this set of code into our current sketch, but not all of it, you'll see. So first, how about we start with all of these? Actually, the preload function too. Okay, so I'm actually going to declare these as letter variables, and then let's do ml5 variables here. Okay, so because we already have preload function here, so I'm just gonna cut this, put it inside here. All right. Next, we want to create these video stuff inside setup. Oh, and also we're going to change the size of the canvas to 640 by 480. So replace this. Just gonna delete the comment for now. All right, next we're going to draw the webcam. And then we're gonna detect the lips here. Inside draw. Okay. And we need to make sure that we have this callback function. Let's put it at the bottom. Okay. Let's click run. Ooh. Oh, don't forget to also import this or reference this library, right? And all you need to do is, if you go back to faceMesh website here, you see that you basically need to import the ml5.js library into the index.html file. So make sure that you come to the website and just kind of play around with examples and also read the documentation just to see how things work. It will be very helpful. So I'm just going to copy this, go back to my index.html file, and then here, going to add it to my as a source file. All right, so hopefully this works. Yay. Okay, so I just want to show you two things before we move forward. The first thing is, if I unhide this, you can see that this is where the video is being displayed at the bottom, and that's why we just hide it. We don't need it. And then the second thing is, look at this. This is my right hand, but the image is mirrored. So what we want to do is also, we want to actually flip both the model and the video. And what we need to do is, so it's a flip horizontal here, but I usually use flipped. Sure it's the same, but I'm actually going to use flipped for now. Set it to true. And then now the model is flipped, but the video is not yet flipped. So my right hand, you can still see from the video as being not mirrored. So we also need to do the same thing here. Flipped true. And put it as the second argument into the create capture function here, and make sure that you put it inside the curly bracket. Okay, that's good. All right, so that's good, but it doesn't do anything yet, right? Because we have not actually merged or integrate them together. So before we do that, let's just fix some of these colors. How about that? So I'm going to actually first, for the rectangle here, let's do stroke of this green color, but let's do no fill. But then for the letters, I'm going to actually set the color to, how about white, and do no stroke. So that's what we want to do. We want to like blow on this and then let it just like kind of go. But right now the mouse is it should still works. Yeah, but we want to actually use the mouth instead. So that's what we're gonna do next. So now what we need to do is that we need to calculate this blowing action, right? So how are we going to do that? So first I'm going to create two vectors actually. One for the top left corner and then one for the bottom right corner of the lip, which are going to be based on these locations. So I'm going to call it top left lip be equals to create vector of this. All right, and then bottom right lip will be based on the width and the height, but it has to be not just the width and height, right? It has to be coming from faces of 0.libs of x plus the width, right? And same thing for the height, it will be dot y plus the height. Just to make sure that this is correct, we're going to draw top left lip dot x, top left lip dot y. Let's do a size of 10. Do the same thing for the other point. All right, so you can see there are these 2 points, and then now what I want to do is that I want to find the distance. You see, the distance between these 2 points, which are different when I open my mouth. So what we want to do is, so I actually am going to delete this rectangle. We don't need it. And then let's call it lip distance. And we're going to use the function called dist, which calculates the distance between 2 points, right? We need to provide 4 arguments. And what we want is top lip dot x, top left lip dot y, and then bottom right lip dot x and bottom right lip dot y. And I just want to print it out so you can see what it is. So right now I close my mouth. It's around 66, 60, 70. I open my mouth, it's around like 120. So you can see that it's different, right? So what we want to do is we need to write a conditional statement. But before that, we're going to basically set another variable. Let's call it this previous lip distance. And this is going to be, every time it is updated, right? It is going to be the new lip distance. So we want to see the change in the distance of the lip. So basically we want to check if the previous lip distance is at a certain amount, which is when the mouth is open, and then the change in the lip distance is greater than a certain amount, meaning it looks like I am blowing on this dandelion, then we are going to trigger, basically call the trigger function. So how about we do exactly that? So if previous lip distance, how about we just set it to greater than, let's do just 90, so we don't need to like just open our mouth too wide. And previous lip distance is, how about let's just start with greater than, minus lip distance, right? So we want to get the change. Let's maybe start with greater than 5, maybe. Then let's just print out the word triggered. Okay, and how about we declare previous lip distance as global here? Okay. Let's try this. You see that? It's working. So it's triggered when I move my mouth in. Okay. All right, so what we want to do now is basically, instead of just printing triggered, we want to call this trigger function. But if I put all of these ring stuff inside the face mesh, it means that nothing will be displayed if the face is not detected. So what I want to actually do is, we're going to be writing to nested loop. So I'm going to delete this part, and then we're gonna put it in here. So basically we need to copy this. All right, so what we had, okay, let me just finish this and then explain. All right, so before, what we had is that when this conditional statement is true, right, we just print the word triggered, which we did to show that we have this blowing action. But then now, instead of just printing the word trigger, what we're going to do is that we're going to call all of the letters here. We don't need this mouse press anymore. And then we're going to call the function triggered. But instead of setting the mouth to this create vector function with x and y positions for the mouth, we actually want it to be, the center of the lip, right? Which I guess before we could use center x and center y. Why don't we actually try that? So what I'm going to do is I'm going to comment this out and then try that first. So what am I trying? Okay, let me show you. Let center lip to be create vector of faces of 0 dot lips, and I think it's center x, I think, and center y. Oh, where did it go? All right, and then how about we just draw it out? Center and center. Let's see. Yay! It's this point over here. Perfect. Great. So we don't actually need to calculate the center point ourselves. So now what we need is uncomment all of this, and then this mouse x mouse y will be replaced with center lip x and center lip dot y. Okay, I think so. I think it's working. Maybe just to make sure that it's really working, why don't we make it a little bit more higher magnitude, and then I don't really want to draw out the ellipse anymore. Yay! Okay, I think it's working. All right, so I think I'm just gonna end the video here actually, because it's probably is quite long already. But there's so much that you can do with this, right? First, you see that all of the letters are falling off the screen. How do we actually make sure that, you know, we remove them from the erase if you want to do that? Second part is, what if we want to make a bunch of the dandelions, right? And then you just blow each one, and you can also play around with the colors. So many possibilities. So I hope that you really like this one because I really enjoyed it, and give it a try.